My name is Andy Harris. I'm the originator of the Game On event for Science Olympics, and I'm very excited to see this event taking on bigger usage, and I'm looking forward to seeing how it goes in the other states and beyond. So if you have volunteered to help coordinate or judge this event, this video is just some instructions, some help for you on how I lead it, and some thoughts about how you can move forward from here. So there's a couple of things to look at, and I'll try and include these in the comments. First, if you haven't already been there, you can take a look at this website, cs.iupy.edu/a harris/gameon. I always have copies of my score sheets that I've been using, as well as the original competition rules. Of course, if there are newer rules for your particular competition, use those. But these are always available for you to download and print out on your own, and I'm going to go over them really quickly. So as the course was, or as the project was originally designed, we didn't have any programming in Science Olympics at all, so we decided to have something that would be good for beginners, even if they're not getting programming support at their school. Eventually, I hope to see us do a full-blown programming contest in traditional languages like Java and C++, but let's just get anything going at this point. So the basic idea, of course, is to use the excellent Scratch tool from MIT to build a game. You can go directly to scratch.mit.edu. These days I do not recommend downloading because people are fussy about putting stuff on their labs. So all you have to ask for is, can I have a web browser? And any modern web browser will handle this. Make sure you check it out yourself first, just to be certain you kind of know how the interface goes. We have seen a few students who had no idea what they were doing kind of tossed into this event. So you may want to have a person or two on your judging team who's ready to help them out. Okay, if they lost, we don't want anybody crying. We want to make sure everybody makes something and has some fun, right? So here's the basic tool, and if you haven't learned how to use it, I have some wonderful videos I can show you. Really, really great stuff. I'm going to recommend that you just run it in the browser in the labs. I would come in and have them set up full screen on every lab or every station in your lab, and then just make sure you have a proctor to ensure that people don't use the browser to open up any other tabs. There's no reason for them to be anywhere else. Of course, we don't want them downloading assets or completed games or anything like that, so just watch for that. Haven't had any trouble, but it'll happen someday. Alright, so there's the Scratch environment. Just have that going on the screen when the students get there. I recommend that whatever lab you've got, typically if I have a 30-seat lab, then I will bring in 15 teams at a time, put all the teams on one side, and let them go first, leaving the other side empty. That way, if we have more than one heat, and we always have, then you can be judging the A heat while the B heat is going. And that gets you through the day a whole lot faster. Typically, my goal is to have one group judged before the other group leaves, and that's pretty good. That means you're only going to be 40 minutes after the last session, and all your grading should be done. So that's a really good goal. If you can't do that, there's some alternatives, but I really prefer to do it that when a group is finished, I like them to stand up and leave with their projects saved on the screen, leaving them on the computers. That way you can have the judges go through and judge them on the actual machines as they go. Alright, so let's take a look at some of the rules that we've set up, and these are really pretty much the same rules. This is not a bring your own packaged event. Everything should happen during the competition. We're not going to allow external resources, so they can't bring in a thumb drive or anything like that. Can't go to the internet and download stuff from their own server. During the competition, each team was supplied with one computer, so it's 2 players per team on one computer. No need for any other software. Paper and pencil are encouraged, and I often supply them. Generally, we'll come up with a theme, and it doesn't matter too much. I like science themes. Keep it general enough that they've got some freedom. Unfortunately, they're not yet sophisticated enough to do some of the really fun things I'd like to do. I'd like to do, Newton's third law or orbits. But we're not quite ready for that. Generally, I've been doing stuff like earthquakes or fire or buoyancy or gravity, stuff like that. Doesn't really matter. Have some fun with it. The goal of the theme is to keep them from simply practicing something and then just spitting it back out. So they have to somehow respond to your theme. So you want your theme to be specific enough that they have to be a little bit original. Talk to your judges and see if you got any ideas. Usually they have a good time coming up with stuff. So then they'll have to make the game. The scoring, I'll go over the score sheet more specifically because that's usually what people have some confusion or concern about how to do it. But don't panic. It's designed to be as easy as possible. Let's see, I got the score sheet here somewhere. Let me show you mine. You can download my little Excel file if you want. Or use your own or whatever. Basically what I'll do is I'll print out at least one of these per computer. Often I'll print one per team. And this is nice because it allows us to write down quickly our thoughts about each project. So you write down the team name, the project, and then the judging is broken into two broad categories, mechanics and gameplay. Mechanics would be more like, well, sort of the more technical side of things, and gameplay as well. Is it fun? So let's take a look at these things. Some of these categories are 5-point categories, some are 10 points. I'd love at Nationals some input on how this should be rebalanced, but for now these are the point scales that we have at the moment, and they're working okay. So let me explain what I was thinking when I generated these particular categories. Intro. Every game should somehow explain what's going on. It should set the scene. So that can be a splash screen, that can be just some instructions, it can be something. Somehow we need to let the user know what's going on. Related to that can be help and instructions, setting the mood, telling the user what the inputs are. Is this a mouse-controlled game? Is it buttons? What's happening? Who are you? What are you trying to do? And these two things could be related. You might have the same judge look at both of them. User controls. Most games, well, if it doesn't have user input, it's not a game, it's an animation. So somehow there's going to be some sort of input. Typically, these will be keyboard or mouse. We don't have joysticks in the lab, and I don't recall Scratch doing that. There is a webcam interface, but you can decide for yourself if you're going to allow that. Most public labs don't have webcams. So almost always you're going to have some sort of keyboard or mouse input. So we're looking for that. How well is that done? One thing to watch is that more sophisticated students will know ways that if I press an arrow, it will give me continuous motion. Less continuous students, it'll move once, and then it'll stop. And so you want to be able to reward that. Autonomous behavior. There will probably be something in the game that moves on its own, some sort of an enemy or a target or something that moves on its own. Now this won't necessarily be continuous movement. It might be random motion later, but this is your chance to look for that and give it some credit when it happens. Most video games involve collisions. Collision detection is a key part of 2D gaming and 3D gaming for that matter. So are they doing some collisions? How sophisticated are they? Are they having some fun with it? When two things collide, do they separate or do they stay in the same place and then you have multiple collisions? Scoring, is there some kind of scoring mechanism? Points are great, they're not the only thing, but there ought to be some kind of feedback happening during the game. Sometimes there'll be multiple scoring systems. For example, you may have a number of lives and you maybe have points, so you want to increase the number of points and avoid losing lives or something. So we're looking for the sophistication of that scorekeeping mechanism. Is there any at all? If there's none, give it a 0. If it's amazing, they've got 5 different kinds of scoring, we'll give them a 5. If it's somewhere in between, well, give them a score somewhere between. Debrief. When gameplay is done, we need to be explaining what happened. Did you win? Did you lose? Did you achieve some goals? What should you do the next time? Is it easy to restart the game? That's what I'm thinking of for debrief. A documentation, I'm really talking about internal documentation. There's some things that you should know about as you're judging these. Sorry about that. And that is inside Scratch itself. So let's say I had some code going right here. Well, there's a really neat thing they can do. They can right-click on any tile and add a comment to it. And so you're looking for those. I'm going to move and rotate. So you look for those. They can also place comments just anywhere, and that's a great thing. Here is my overall comment for the entire game. The best teams will have that very visible and very easy to see. There's other kinds of documentation that are legitimate. For example, sometimes I'll see people build just a backdrop where they draw out, a general plan for their game. Here's going to be my planet, here's going to be my spaceship, okay, and it's going to have little rockets that come out of it, and it's going to go this way. I mean, so if they do something like that, super, count that. Give that some credit because that's really good work. I really, really encourage that. Of course, that's probably not the backdrop they'll use for their final game. They'll go, load something up. Whatever. We're only allowing, actually, sorry, I shouldn't have done it that way. We're only going to allow things from the library. But I don't know, my space game will happen at Berkeley because why not? Okay, so there you go. That is that's documentation. Notice documentation is important. Somehow they have to be explaining what they're doing. Also, we have code organization. This is another really important thing, and that is, did they organize their code well? Now, this would be a good place if you have a programmer on the judging team to use the programmer, because they will understand some things like this. First of all, again, you can reinforce commenting. Is all of their code just all willy-nilly, or did they use some tools to break it up? Modern versions of Scratch have both the create a custom brick and the message passing mechanism. These allow us to make our code more organized, much easier to follow. So you want to give people credit for doing that if they did. And we're even looking at simple things like, did they bother to make things, well, line up nicely? So, if I have stuff here and I have another chunk of code here, is it all just kind of haphazard, or did they try to make it organized well so you could see what's going on? We want to reinforce those good habits as they become, programmers in more traditional languages. Okay, so that's basically the mechanics, and these are areas where if you have somebody who's done some game development, they will probably prefer to work in these areas. The other ones are suitable for anyone to judge, really, and that would be theme. So theme is probably one of the most important categories. Don't just give this away. How well do people adhere to the theme? And generally, not very well. Most of the contests I've seen, most of the students don't get better than about a 5 for the theme. So if my theme is space and all they've done is made a black background, I'm going to give them 1 or 2 points for that. If the theme is space but they've acknowledged Newtonian motion, for example, or they've included orbital gravity or something, well, now we're talking. Now we're talking about a really nice score here. So be pretty picky about this one. Graphics. Of course, this is where the students will tend to really do the most work, and they really shouldn't. I recommend students don't spend too much time on graphics, because what we see all the time is they make it look great and it does nothing. Then it's not a game, it's a picture. So for graphics, great. We want great graphics. Remember, they should be done in real time. Generally, they can modify the stuff that's in the library. You can usually find something that gets you pretty close. Sound. In a perfect world, I think I would change documentation to a 10-point category and sound to a 5-point. And the reason is almost nobody does it. There are stock sound effects, and they're welcome to use them. It's amazing how many games do not use sound effects at all. Now, most of these public labs do not have speakers, and you don't want them running anyway. That's why we recommend participants bring their own headset with a microphone. I recommend you bring one that you can loan out, so that those teams who want to do something with sound effects can. There's a decent little audio editor built into Scratch, so if somebody builds custom audio, I would definitely give that a little more. You'll find a lot of people throwing away a lot of points in this category. That's interesting. Play balance, this is really well, is it fun? Did they think through the difficulty level? Did they think through a game that was appealing and interesting and and people want to play? Did they think through the difficulty level so it's not so crazy easy that it's dull, or so crazy difficult that nobody can do it? It's a very difficult thing to do in gaming, but we're really rewarding them for trying at this point. And so you want to give them some sort of score for how well they did that. Now, the overall impression category is interesting. I like to save this. Now, the practical aspect of this is that if I have, say, 5 judges, I will have each judge pick a couple of categories that they want to do, and then I'll have that judge do those categories for every single assignment. So, Sarah wants to do help and instructions and intro. Great, Sarah, awesome. Run with that, but I want you to do that for every single project. And the reason for that is then Sarah's going to be consistent with herself on what those 2 things are. That works a whole lot better than Sarah doing one game and Joe doing a second game, and we don't know if Sarah and Joe agree on what all of these things mean. So I'd rather just have a person doing a couple of categories everywhere. That way we're much more likely to have internal consistency. Also, everyone will have seen everything. So everyone will have seen every game, and they're keeping an eye on what they think of overall impression. So generally, after all the scoring is done for a category, I'll set the overall impression scores to 5 and put them all up on a spreadsheet. If you've got a projector in the room, super, use it. And then when we look at those, we take a look, just balance them by their overall total score. And if you're using my spreadsheet, I've already put the formula in, so you're welcome. You've got the total score, and then you can figure out, okay, did the top 5 turn out like we expected? Have the group discuss that. And if there's consensus, great, lock it down. But if there's not, then you can adjust this overall impression score up and down to make sure that those top 5 scores are where the team thinks they should be. Now, you really don't want to do this when there's students in the room, so you want to wait until the other students are gone to have these discussions. But you want to do that. The other thing I'll do with the overall impression score is eliminate all ties. Now, it's okay to be harsh in your grading. In fact, it's probably a good idea to be harsh in your grading, because the goal here is not 100 points. The goal here is to separate them. The students will never see the final raw scores, so you need to make sure that these scores are separated. I would emphasize that to the judges. So it's okay to be a little rough. If everybody's getting 9s and 10s, you're not going to have separation. You're going to have a hard time. As the leader, once your team is happy with the scores, we'll print it out and write it on the official score sheet, and that'll be pretty fun. A couple of more things to show you. If you want some tips on how I look at these games, I've got, where is this here? On my YouTube channel, and I'll put a link to this in the comments. Probably where you found this, I also have a video of myself entering the contest. So I'm saying, okay, if I were me, how would I do the buoyancy contest? And so I'm do a game from beginning to end, walking through some relatively sophisticated physics and so on. And this shows any participants how I think about it. It might be useful for you too to see, oh, that's cool, that's how Andy does it. He's wrong, but okay. And that's cool with me. So you might want to take a look at that at your leisure and see how I'm kind of looking at this, and see if that helps you. Again, if you have any questions, please don't hesitate to drop me an email. Let me know how it's going. I can't wait to hear what you're doing. And thanks again for being involved in this process. All right, have a great time. See ya.